Welcome back again, and this is going to be probably just a really short video. Um, you know, right after I finished recording this lesson here about dynamic Stargate systems, I just realized that I forgot to talk about something very important. Okay, as we know, these two stargates are going to be communicating, as we talked about. Um, okay, and the distance, d is the distance here. But you know, what is the physical mechanism that would be behind actually swapping the things here? Okay, in the Stargate system, there would be a device. There would be a device like a digital controlled oscillator, really. Okay, but if you haven't much experience about with electronics and oscillators and test equipment and things like that, let's take a function generator for example, a signal generator. On the draw a really simple picture of it here. Okay. Okay. At the top here, this is my really ugly picture of a signal generator. We've got the knob here. Knob here we can turn to dial up whatever frequency we want. Okay, let's just assume this is an AC signal generator, and the output is just going where these arrows are. One of these would be ground. Blah blah blah. Not really important, Okay, but you notice a lot of these signal generators that you buy on the market now will have a little BNC connector on one side of it. It'll say like TTL sync in or something like that, and basically, or it'd be like it'll say external trigger. Okay, and really what that would mean is, okay, if you dial it up to say 100 hertz, 100 cycles per second, it's going to produce a constant 100 hertz signal. Okay, but if you put in an external trigger, you can actually create a modulation to that 100 hertz signal. So it won't be exactly pure. It will actually carry information based on its waveform. Okay, and so that's what we have at each quadrant here. We have a different part. Okay. Um, let me illustrate this a little better. Okay. Let's not worry about the distance lead here. Okay, imagine from here to here is the entire pulse train of the Stargate address. Let's say it goes here, and here, and here, and here, and here, and here, and here. Okay, so maybe this is what the pulse train of our particular address would look like. Okay, so now what we're going to do is this modulation will be flowing in a circular path through this Stargate. And now what's going to happen is when we divide the Stargate up into quadrants, we're going to 1, 2, 3, 4. Yeah. Okay, so it's going to be Q1, Q2, Q3, Q4. Okay, and this is really what we need to understand. This is the waveform that's going through the coils or the conductors or whatever it happens to be. Okay, so now if we want to, at each quadrant, there will be a different, there will be a different signal generator with an external trigger. Okay, this external trigger it can be connected to an antenna. Okay, let's draw a little antenna out here. All right. Okay. Now this antenna right here would be listening to the data coming from the diagonal diagonal quadrant of quadrant 3 on this Stargate from point B, and each one will have it like that. Okay. Now here comes the kind of teaser question. We know that these are just going to be regular electromagnetic signals, and we know they can only travel so far before the signal gets deteriorates and it just drops off, and the signal to noise ratio will be so terrible that we can't, we just have too many data errors. Okay, but okay, now how long does it take to get from point B to point A, this radio signal? And the answer is instant. Because, okay, we have to remember, we've already established this wormhole, and now we're just swapping quadrants. So actually, it's just like placing two radio sets, two walkie-talkies, the antennas, putting them right next to each other, almost touching. That's how close it is. Because this electromagnetic signal is just passing through the event horizon. It doesn't have to go millions of miles, hundreds of thousands of light years to get to the other one. It's not needed. And so, that's the biggest question that I guess somebody asked me. Okay. Yeah, so this is very important stuff. And there are a few things I guess I could talk about on this still. But really, I don't want to go into too much electronics jargon for right now, because a lot of people have told me they really don't know anything about the electronics side of this. But some of us do know. We do have this kind of background, so sometimes I will be talking about it because it makes it easier to understand, and electronics isn't very difficult at all. All right. Okay, so to recap, in order to the actual technological mechanism that will do the swapping is a combination of off-the-shelf technologies. Really, we have a regular sine wave signal generator with an external trigger. Okay, and then that is connected to a radio or antenna that is receiving information from the opposite quadrant of the opposite gate, and that's how things get switched about, and that's how we can travel vast distances in less than a second. Just stepping through the doorway, and we're there. Traveling the way that gods travel. Okay, so if you have any questions, think I'm crazy or whatever, nobody's actually left any comments on this before. I don't know if anybody's. I don't know what you're thinking. So if you think anything about the series of videos, whether it's good, bad, neutral, anything is okay. Okay. And the other thing that I was kind of thinking about, first of all, I am not a math genius. I'm not a math expert. In fact, the math that I know is math that seems to just describe things in nature or things that are of a very practical nature. So, to me, this looks like This looks like calculus. However, at the same time, I think this is a lot simpler than calculus, and it's based on geometry. It's not really based on the kind of calculus and pre-calculus that I learned in school. And unfortunately to say, the calculus that I forgot because I couldn't really find any good everyday applications to it. Okay. But yeah, if you could, if somebody that's really good at math can explain to me what kind of mathematical techniques this happens to be using, I'm very interested to learn all about it. Okay. Okay. Well, thanks for watching, and this is over.